Good morning guys! Welcome back to our channel. And today's lesson, we are going to talk about continuity, and it's more about limits. Are you ready? Let's go! So, how can we prove if a function is continuous at a certain point? A function is said to be continuous at x is equal to c provided the following conditions are satisfied. First, f of c is defined. What does it mean? In a given function, our x is equal to c, and if our c equals for a certain value, then that value defines our c. Number 2, limit of f of x as x approaches c should exist. Take note that it should be taken both sides. Two-sided limit should exist. And for number 3 rule, the limit of f of x as x approaches c should equal to f of c. What does it mean? If our value in rule number 1 and in rule number 2 are equal to one another, then we validated the third rule. So take note, if one or more of the mentioned conditions failed to hold at c, the function is said to be continuous at x is equal to c. Now, let's start to solve a problem regarding this continuity. Are you ready? Let's go! A function is said to be continuous at x is equal to c, provided the following conditions are satisfied. Number 1, f of c is defined. Number 2 condition, the limit of f of x as x approaches c should exist. And for the last condition, the limit of f of x as x approaches c should equal to f of c. The three-step test for continuity. Given the function f of x is equal to x squared minus x minus 6 over x minus 3, if x is not equal to 3, and 2 if x is equal to 3. Given the function, let us draw a sketch of the graph. As we can see, the value of our x is 3, and it is also given that if x is equal to 3, our f of x, which is also considered as y, is equal to 2. Technically, we have a given point of 3, 2. Now, let us try to find out if the given function is continuous or discontinuous. Number 1, f of c is equal to f of 3 equal to 2. Now, f of c is defined based on the given functions above. Number 2 condition, the limit of f of x as x approaches 3 is equal to x squared minus x minus 6 over x minus 3. Let's substitute the value of x, which is 3, to x, equals to 3 squared minus 3 minus 6 over 3 minus 3 equals to 9 minus 9 over 3 minus 3 equals to 0 over 0. As we can see, 0 over 0 is undefined. That's why we are going to find the equivalent function. F of x is equal to x squared minus x minus 6 over x minus 3. Now, notice that x squared minus x minus 6 can be factored out as x plus 2 and x minus 3. And we can cancel out the x minus 3. Therefore, what will be left is x plus 2. The limit of x plus 2 as x approaches 3 is equal to 3 plus 2 equals 5. Third condition, given that f of 3 is equal to 2, 2 is not equal to 5. So by checking the third rule, the limit of f of x as x approaches 3 is not equal to f of c. As we can see in the graph, the functions get discontinuous at point 3, 5. This type of discontinuity is what we call jump discontinuity. Therefore, f of x is discontinuous at x is equal to 3. Just to add another information, there are 3 types of discontinuity, which are jump continuity, infinite discontinuity, and removable discontinuity. So guys, remember for the theorem of continuity, if the functions f of x and g of x is continuous at c, then f of x plus g of x is continuous at c. F of x minus g of x is continuous at c. F of x times g of x is continuous at c. Now, f of x divided by g of x is continuous at c if g of c is not equal to 0. But if g of c is equal to 0, then it is said to be discontinuous at c.